Hello, this is Mrs. Ward. I'm going to go over the homework for sections 1.3, which is evaluating limits analytically. So the first one and 1 through 4 says use a graphing utility to graph the function and the visual estimate of the limits. So I pick up my calculator, I type in x times cosine of x, and I had to put that multiplication sign in. And when I do this, I can see that it appears to be continuous. So when I go to Control T and look for 0, I get 0 is equal to 0. So for part A, the limit as x approaches 0 is going to be 0. The second one is asking me to find pi over 3, which is obviously not an x value on my table. So I'm going to hit Menu, Trace, Graph Trace, and then I want pi. So pi divided by 3. And when I do that, I get 0.5236. And if I didn't do that on my calculator and I just substituted in, I would get the same answer. So if I do direct substitution for the first one, I would have 0 times the cosine of 0. Well, 0 times anything is 0, but the cosine of 0 is 1. I'm still going to get 0, and that's what I got on my calculator. On the other one, I would have pi over 3 times the cosine of pi over 3. The cosine of pi over 3 is 1/2, so this would be pi over 3 times 1/2, which would be pi over 6, which if I do that on my calculator is that 0.524 that I got on my calculator. Okay, the next one's find the limit. So if I can do direct substitution, I am going to do direct substitution all day long. So this will be -2 raised to the third power, which is -8. So that limit is -8. In number 9, I'm going to have -3 squared plus 3 times -3. So this will be 9 minus 9, which will be 0. Number 12, I'm substituting in 1, so 3 times 1 raised to the third minus 2 times 1 squared plus 4. So this ends up being 3 minus 2 plus 4, and that limit is going to end up equaling 5. Number 15, substituting in a 1, I'm going to have 1 minus 3 over 1 squared plus 4. So this is -2 over 5. Cannot simplify it, so this limit is -2/5. Number 18, putting in the 3, I'm going to have the square root of 3 plus 1 over 3 minus 4. So this is the square root of 4 over -1, and that'll end up being 2 over -1, which is -2. And last one, number 21, I'm going to have -4 plus 3, that quantity squared. So this will be -1 squared, which is a +1. So direct substitution, do that all day long. Number 27, find the limit of the trig function. So remember, you're just still doing direct substitution. So I'm going to do the sine of pi over 2, which will be 1. Now I'm going to do the sine of 5 pi over 6, which is a 1/2. 30, I'm doing 1, so this will be the sine of pi times 1 over 2, so the sine of pi over 2, which is 1. Secant of 7, as x approaches 7, so this will be the secant of 7 pi over 6. I really don't know the secants, but I do know the reciprocal, and the reciprocal of secant is cosine. So this cosine of 7 pi over 6 is a negative square root of 3 over 2. So the secant is the reciprocal. So that would be a -2 over the square root of 3, rationalizing -2 squared to 3 over 3. And that's my final answer. Number 39, they want me to find the limit. So it wants me to find the limit of x as x is approaching, the limit of f of x is 4. Then I want to find the limit as x approaches c. So this will end up being 4. No matter what number this is, it's always going to be 4. So 4 raised to the third power is going to be 64. The next one, I want to find the limit of f of x as x approaches c. So that's going to be the square root of 4, which will be 2. Then I next one, find the limit as x approaches 3 of 3 times f of x. Well, f of x is always 4, so that's 3 times 4, which is 12. And the last one, find the limit of f of x. Remember, f of x is always 4. And I'm raising 4 to the 3/2 power, which means I'm taking the square root of 4 and raising that to the 3rd power. So to the 3rd, which will be 8. And that's how I do those ones. The reason why I didn't need a c is because this is equal to a constant. Next one, number 42, it says use the graph to determine the limit visually. If it exists, write a simpler function that agrees with the given function at all but one point. So look, let's do the first part. I'm looking at this graph. It wants me to find the limit as x approaches -2. So x is approaching -2. So from the left, it appears to be -5. And from the right, it appears to be -5. So this is going to be -5. Find the limit as x approaches 0. So approaching 0, from the left, it looks like it's -3. From the right, it looks like it's -3. So this limit is -3. Then it asks me to write a simpler function that agrees with the given function at all but one point. So from the numerator, I'm going to factor out a 0. I'm sorry, I'm going to factor out an x and make it x times x minus 3 all over x. Here the x's will simplify, and my simpler function, which I'm going to call g of x, is going to be x minus 3, which is why I have this straight line. All lines are straight. Though I have this line with a y-intercept of -3, and it looks like it has a slope of 1. That matches that equation. Next one, find the limit of the function. If it exists, write a function that agrees with the given function at all but one point. So when I did number 45, I'm actually going to do this in opposite order. When I go to put in 1, -1, I have -1 squared minus 1 over -1 plus 1. And now I end up being 0 over 0, which tells me I can simplify. The numerator factors is x plus 1, x minus 1. The denominator is that x plus 1. So the function that agrees at all but one point would be this function that I'm going to call x minus 1. Now to find the limit of that function, so to find the limit as x approaches -1, I'm going to do x minus 1. I'm going to do -1 minus 1, and I'm going to get -2, which means all the way back up here, this limit is -2 because they agree at every point except for when x is equal to -1. Okay, number 48, if I put in 1, I'd have -1 to the 3rd plus 1 over -1 plus 1, and I would get that 0 over 0, which tells me that I can simplify and I can find the limit. The numerator is the sum of two perfect cubes, so that's going to factor as x plus 1, and then this will be x squared minus x, when I multiply those two, plus 1, all over x plus 1. Here the x plus 1s will simplify, so my new function that agrees at every point except for the one point, which is -1, is that x squared minus x plus 1. Now I'm going to find the limit of this function as x approaches -1, so this will be -1 squared minus a -1 plus 1, and when I do all that, I get 3, which means the limit up here is also going to be 3. Number 51, find the limit if it exists. If I first start putting in -3 squared plus -3 minus 6, I'm going to get 0 over 0. I would get 0 over 0, which means something can simplify. So I'm going to factor the numerator using product sum that factors as x plus 3, x minus 2. The denominator factors as x plus 3, x minus 3. So the x plus 3's will simplify. I'm left with this new function that's x minus 2 over x minus 3 that agrees at every point except when x is equal to -3. And I'm going to take the limit as x approaches -3. And when I do that, I'm going to -3 minus 5 over -3 minus 3. And that'll be Oh, minus 2. Whoopsie, minus 2. So it'll be negative 5 over negative 6, which is a positive 5, 6. So this limit is 5 over 6. Number 56, if I put in 3, I'm going to have the square root of 3 plus 1 minus 2 over 3 minus 3. And this will be the square root of 4 minus 2 over 0, which is 2 minus 2, so 0 over 0, which tells me that I can simplify, which means I see that I have a radical, which means I'm going to multiply this by the conjugate, so the square root of x plus 1 plus 2. When I multiply the numerator, I'm going to have x plus 1 minus 4 over x minus 3 times the square root of x plus 1 plus 2. Numerator will simplify to x minus 3. X minus 3 so the x minus 3's will simplify, and I'm left with 1 over the square root of x plus 1 plus 2, and I am going to take the limit of this as x approaches, I believe, 3. So now it's okay for me to do direct substitution, so I'm going to have 1 over the square root of 3 plus 1 plus 2. So that's 1 over the square root of 4 plus 2. The square root of 4 is 2, so 2 plus 2 is 4. So I'm going to get 1/4, which means up here, this whole limit of this is going to be 1/4. Okay, moving on to the next one. 67 is that sign. Remember, that's one of the two properties that I have to know. So the property is the limit as x approaches 0 of the sine of x over x. So in order to, and that's equal to 1, to make that look like this, I need to take care of this 5. So I'm going to rewrite this where I take 1/5 outside and multiply that by the sine of x over x. And that I take 1 times the sine of x, 5 times x, and I would end up back with this. This 1/5 technically comes outside. I'm going to take 1/5 times the limit of x approaches 0 of the sine of x over x. This whole limit is equal to 1, so 1/5 times 1 is going to be 1/5. I think we did that one in class. 67 is also another limit, so if I put in z, I would get 0 over 0, so I know it can simplify. So tangent squared, I'm going to think of as sine of x times the sine of x over cosine squared x, and I think I'm going to put cosine squared x like that, all over x. Now what I'm going to think of is I'm going to think of as though I have two separate, I'm still taking the limit as x approaches 0. So it's like I'm going to take the limit as x approaches 0 of the sine of x over x times sine of x over cosine squared x. So if I separate this, which I don't know if you would write it like this or not, but I'm going to. So this limit of this sine of x over x, that's going to be 1. Here I can do direct substitution. I'm going to have the sine of 0 over the cosine of 0 squared. So the sine of 0 is 0, but the cosine of 0 is 1, so 1 squared. So it's okay for me to have that 0 over 1. So this is going to be 1 times 0. So my whole limit is going to be 0. So my whole limit up here is just going to be 0. Okay, number 85, I have to tell you one of my favorite problems. So what it's asking me to do is find f of x plus delta x. So in this equation, every place I see an x, I'm going to write x plus delta x. So I'm going to have 4 over x plus delta x. That's this part here. Then I'm doing minus f of x. So here's the minus f of x, which is just 4 over x. And I'm putting this whole thing over delta x. And I'm trying to take the limits as delta x approaches 0. If I put 0 in, I'm going to have division by 0, and I do believe I end up with 0 over 0. Yes, I would. So I can simplify it. So let me work on simplifying it. To combine the numerator, because it's going to be easier for me to combine the numerator. To combine the numerator, I have to have a common denominator. So my common denominator is going to be x plus delta x. That whole thing is going to be times x. So this fraction, I'm going to multiply by x over x. And this fraction, I'm going to multiply by x plus delta x, both the numerator and the denominator. So when I do that, I'm going to have 4x minus 4 times x plus delta x. And this is all over delta x. So distributing that negative 4, I'm going to have negative 4x minus 4 delta x over x times x plus delta x. And this delta x is understood to be over 1, and I'm dividing by it, so I'm going to think of it as multiplying by the reciprocal, which is 1 over delta x. Here, the negative 4x, that should have been positive 4x. The positive 4x minus negative 4x, the 4x minus 4x is going to equal 0. So I'm going to have negative 4 delta x over x times x plus delta x. I'm going to multiply by 1 over delta x. And this whole time that I'm doing this, and I haven't been writing it, I've been pretty bad about writing it, I'm finding the limit as delta x approaches 0. Still can't substitute in 0 because I have division by 0 for part of it. I am going to simplify these delta x's, still taking the limit as delta x approaches 0. Now I have negative 4 over x times x plus delta x. Cannot simplify any further, but I'm going to go ahead and put this 0 in for the delta x. So I'm going to have negative 4 over x times x plus 0. So I'm going to end up with negative 4 over x squared. And that's it. That's what I got. That's it. I'm leaving it like that. I'm not finding a value. I'm finding an equation. Actually, what you did is you found your first derivative, but we'll talk about that more later. But that is how you leave it. That is your final answer. Okay, the next one are true and false. The limit of x as x approaches 0 of the absolute value of x over x is 1. That is false. Because what's going to happen is if I'm graphing this, from the left it's going to approach negative 1. From the right it's going to approach positive 1. Since I'm not approaching the same number, the limit does not exist. The next one, the limit as x approaches pi is 1. So if that can't be right. Oh, that is right. That's an identity. Oh, no. That is not right. Because if it was 0, it would be right. It would be an identity. But this says to pi. So this would be the sine of pi over pi. And the sine of pi is 0 over pi, which will just be 0. So that is false. Oh, the back of the book got that one wrong. Number 15. If f of x is equal to g of x for all real numbers other than x is equal to 0, then the limit as x approaches 0 is L. Then the limit of g of x is also 0. That is true. Number 16, if the limit of f of x is equal to L, then f of c is also equal to L. No, 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 no. That could be a case where I have a graph, and let's say I'm approaching some number, and I have this circle here. So this limit would be, let's say 1, but then I could have this dot, and f of the function could be this number up here, and my limit would be that number. So that one is false. Number 17, f of x is a piecewise function. The limit of f of x is equal to 3 when x is equal to 2. No, that is not the case. So here, this graph, when x is less than or equal to 2, my function is 3. So my graph goes like that. And when x is greater than 2, it's 0. So then it will go like this for the rest of it. So as I'm approaching 3 from the left, my function is equal to 3, and as I'm approaching 3 from the, or 2 from the right, it's 0. So since they're not equal to the same number, that limit does not exist. So this whole statement is false. Number 118, if f of x is less than g of x for all real numbers and x is not equal to a, then the limit also has to be less than, and that's going to be false. Let's say f of x is equal to, let's say 1/2 x squared. And let's say g of x was equal to just x squared. Well, for every value, f of x is going to be less than g of x because it's going to be, the height is going to be half as tall. So it's always going to be less than. But if I wanted you to find the limits of f of x as x approached 0, you would put 0 in and you would get 0. If I wanted you to find the limit of g of x as x approached 0, so I'm approaching the same number, putting in 0 into that function, I'm also going to get 0. Well, 0 is not less than 0. That's not false. That's false. So since I found one counterexample, I proved this whole thing false. So this is false. All right, that's the homework, and I hope it helps. I will see you next time in class.